Hello, everyone. I just wanted to make a quick video for you to kind of go through an example with the arc length here. Um, I may have gotten through getting you the formula here, but I didn't get to do an example. So I want to go through um, how to get the equation, like the formula for the arc length, just in case you missed it, or I didn't get to it in your class. And I'm also going to do an example, which I didn't get to in any of the classes. So let's first find the equation or the formula that relates the circle, the radius of a circle, and the length of the intercepted arc. So again, we're going to have a circle and it's going to have radius r. So our radius will be the length here. And we're going to have um, an angle in the center of this circle. And so again, this angle will be in standard position. So let's say here's my terminal side. And so this is my angle theta. Assuming that theta is measured in radians, we have a link between the length of the radius, the size of the angle, and the length along the edge or the circumference of a circle. So let's just call this arc length along the edge S. And again, the arc length is going to go from basically from the initial side to the terminal side of your angle, and it's going to include the whole circle, the whole part of the circle in between there. That's going to be our arc length S. Now, the link between these three values is going to be that if I take the arc length of S and I divide by the radius, I figure out how many radius lengths are in that arc length. And that will tell me how many radians large my angle theta is. It'll tell me how many radians are inside theta. So this really is the link between our arc length S, our radius R, and our angle theta. Now again, theta must be in radians in order for this to work. Because radians gives us this connection between the radius and the arc length. So we can either say S divided by R equals theta, or if we multiply both sides of this equation by R, we get the length of the intercepted arc is going to be your radius times your angle theta. And again, theta must be in radians to use this formula. You can use either version of it here. It's kind of whichever is more convenient with the information that you're given. So let's try an example here. So we are asked to find the length of the arc created by an angle with a measure of 200 degrees in a circle of radius 9 inches. Okay, so I'm very visual. I like to have a picture, so I'm just going to draw a quick picture here. Here's my circle. My radius here is 9 inches. And I have an angle that measures 200 degrees. So I'm going to put it down here because 200 degrees is a little bigger than 180. So I'm going to say in standard position, we're going to start at the positive x-axis and rotate over this way a little bit past the negative x-axis. So here's my angle theta, which is 200 degrees. And I want to know the length of the arc. That means I'm trying to solve for S. Um, and again, I know that S is going to be R times theta, but theta must be in radians in order to do that. But the angle that I'm given is in degrees. So the first thing I have to do is transfer our angle from radians to degrees. So we have 200 degrees to convert this to radians. I need to multiply by degrees on the bottom to cancel out those degrees, which means I'm going to multiply by pi on the top. So pi over 180 is what we'll multiply by to do this conversion. And when I multiply across, we get 200 pi over 180. You can put this in your calculators to simplify it, or let me see here, 20 is the biggest thing that's going to come out of top and bottom. So 20 out of the top leaves us with 10, and a 20 out of the bottom leaves us with 9. That's as simple as we go. So theta in radians is 10 pi over 9 radians. So now my arc length S is going to be my radius, which is 9 inches, times my angle theta in radians, which is 10 pi over 9. And so now I can just multiply these. 9 times 10 pi over 9. These guys cancel, and I just get 10 pi. And this is an arc length. That means it's going to be a length. Our length here is measured in inches. So 10 pi inches is how long my arc length S is. And again, this arc length is all of this section of the circle. That's going to be 10 pi inches long. All right, hopefully that helps. I hope you have a great evening, and I'll see you on Wednesday.